Today we're going to show you how to solve systems using substitution. Basically, we have two variables, an x and a y, and two equations, and our job is to figure out an x and a y that will satisfy or solve both equations at the same time. So the first thing you're going to do is find the equation who has a variable already by itself. If you take a look here, y is already by itself. We'll show you what to do if it's not later. So what you're going to do, since y is the same as 6x minus 11, we're going to take that 6x minus 11 and plug it into the other equation's y. And we're plugging it in for y because it tells you y is the same as 6x minus 11. So let's take 6x minus 11 and plug it into the other equation's y. So I'm going to copy this negative 2x down and then the minus 3, but instead of y, I'm going to open a parenthesis and put in what y equals, 6x minus 11, close my parenthesis, then I see equals negative 7. Then you're just going to solve that equation. So I'm going to distribute the negative 3. I'm going to combine like terms on my left side. And then I'm just going to solve this equation for x like you know how. But I'm not done yet. I know that x is 2, but I also need to know what y equals. Well, go back to what you circled. It says right here that the y coordinate is 6 times the x coordinate minus 11. So I'm going to write that, y equals 6 times the x coordinate minus 11, and then I'm going to actually plug in what x equals. I know it's 2. So y equals 12 minus 11, so y equals 1. Now that I know the x and the y that will make both equations true, then I'm just going to plug in, or excuse me, I'm just going to write it as a point, 2, 1. Graphically, that's where the two lines intersect. Algebraically, if I plug in that x is 2 and y is 1, it's going to make both of these equations true. So let's take a look at another problem. Let me remind you, the first thing you're going to do is find the equation who already has a variable by itself. In this problem, the y is by itself in the second equation. So since y is the same as x minus 1, I'm going to take x minus 1 and put it into the other equation's y. So I'm going to copy the 2x, the minus 3, but instead of y, I'm going to put what y equals, x minus 1, but in parentheses, and then I see that equals negative 1. And then this is an equation that you learned how to solve back in chapter 1. So I'm going to distribute. I'm going to combine like terms. 2x's minus 3x's is negative 1x. And then I'm going to solve my equation doing all my adding or subtracting first. And then my division to get that the x coordinate is 4. But remember, you're not finished. You need to know what the y coordinate is. So go back to what you circled. It says right here the y coordinate is the x coordinate minus 1. The y coordinate is the x coordinate minus 1. But I know the x coordinate is 4. So I'm going to plug that in, and I get that that y coordinate is 3. Then the last thing that you're going to do is write your solution as a point, x coordinate, which is 4, comma, y coordinate, which is 3. And that is the solution to the system. Graphically, it's where the lines intersect. Algebraically, if I plug in that x is 4 and y is 3, it will make both of these equations true. And we'll leave that for you to check. All right, let's do one more together. Take a look at problem number 3. Hopefully you already know what I'm going to say. Find the equation who already has a variable by itself. In this case, the x is by itself in the second equation. And since x is the same as 4y minus 5, I want you to take that 4y minus 5, but this time I'm going to put it into the other equation's x, because that's what it says. X is the same as 4y minus 5, so then I need to put in 4y minus 5 into the other equation's x. So I'll copy the 3, but instead of x, I'm putting what x equals, 4y minus 5. That's why we call this substitution. Minus 2y equals 5. And then I'm just going to solve. Distribute. combine your like terms. They together make 10y. And then solve. I'm going to add 15 to both sides. I'm going to divide. And now I know the y coordinate is 2. And again, you're not done because you need to know the x coordinate too. But go back to what you circled. It says the x coordinate is 4y minus 5. So the x coordinate will be 4 times the y coordinate minus 5. But since I know the y coordinate, I'm going to plug that in as 2. So I get x equals 8 minus 5. So x equals 3. But then don't forget, your solution to the system is always a point. So I'm going to write that as 3, 2. X first, x, y. Again, graphically, that's where the lines intersect. Algebraically, if I put in that x is 3 here and y is 2, I would get 9 take away 4, which is 5. And this says the x coordinate is 4 times the y coordinate, which is 2. So 8 minus 5 gets me the x coordinate of 3.